Hello everybody, today I'm going to go through the capacitor lab. In the manual I have actually given you the background of this and the theory about the capacitor characteristics, and I'm expecting you to go through this. I'm not going to explain those right now here. So if you're having the course, I'm expecting to read the chapter on that side, although I have summarized whatever you need for this lab over here. So you really don't need to go all and read all the thing in the book, but if you it's good to be familiar with it, and just to start from wherever I have started on the theory, and which gives you the background of what a capacitor is and how it can charge, and then what is the relationship between the charge, capacitance, um, and voltage, and then how is the capacitance of a capacitor changing depending on the area, the distance, and also the dielectric constant of the material, how that one is changing, and also how is the electric field changing. So also how much is the energy stored in a capacitor, and what are the different types of capacitors in terms of the ceramic capacitors or electrolyte capacitors, which I have shown over here how to read them, and so all those information is provided. So I'm expecting you to go through it. Also, how could the capacitors be in a circuit? Can they can be in the form of series or in the form of, and then how can you find the equivalent capacitance of capacitors in series, meaning that you want to replace one capacitor, all the capacitors, and replace another capacitor that has all the characteristics in terms of voltage and charge. And then also how the capacitors could be put in parallel. So here is like how the total capacitance could be found from there. So I'm expecting you to go through these yourselves, as I'm not going to go through it over here right now. And also, if it is a mixed configuration of capacitors in series and parallel, even more complicated case is given over here with an example, which can help you both on the course and on this lab. Also, how are the capacitors charged? So how long does it take for a capacitor to get charged, and how long does it take to get on in discharged? So those are also provided over here for your information before you start the lab. Okay, so here I'm gonna start the lab. Basically, you go to this link that I have provided for you, or you just download it from your Blackboard. And yeah, you need to, so once you download that, which I have already done, and I have this software here, so you just run the software. If you don't have this software, is running based on Java. So if you have not installed Java on your computer, so that's, I recommend you doing it before you run the software. Or if you need and get any help, you can get it from the technical services on campus, can help you on installation of Java that best matches your computer. Okay, so here is the software where it is connected. So it is basically two plates that are connected to a battery. So you can change the voltage of the battery. So what I'm expecting in the first part of the lab is that, so you just look, I have given an example, like if you put the voltage at 1.5, you put the separation. So just let me go to the software. If you put it at 1.5, the voltage, and then you put the separation 10 millimeters and the area being 100 millimeters squared, just, I didn't basically just change anything except that I just put the voltage to be 1.5. And then what I'm what I have asked you, so I have over here written that change it, change it, change it, and over here read and insert, read and insert, read and insert, read and insert, read and insert. So I have given you instruction on what you should do on the very top line. Okay, so I want you to read the capacitance. How do you read the capacitance in this? Capacitance, you have the meters here. You can click on all the meters to bring them over here. Plate charge, stored charge. You also have the voltmeter that you can bring to measure the voltage anywhere you want, and also the electric field meter. So those are all available. You can move them around as you see if you don't like it where they are. But I also have asked to put I mean, you can look at the electric field charge, field lines by clicking on this. So pretty much, I mean, it's nothing more than that. So by clicking on them, it appears. By this unchecking them, they're gonna disappear. So nothing special. So what I'm asking over here to read the capacitance, how much is the capacitance? I read it over here 0.89 10 to the minus 13 farad, or pretty much 0.09 10 to the minus 12 farad is what I have written over here. Remember that this is in picofarad, so you just, which means that times 10 to the minus 12. So I have put everything in pico so that it'd be easier for you to write down the what you read. And then the charge, how much is the charge? Is 0.13 10 to the minus 12, so which is 0.13 pico coulomb. Pico, yes, coulomb, the charge. And then the stored energy, it is 1 times 10 to the 13 minus 13, which is basically 0.1 10 to the minus 12. Then it is also in picojoules. And so I want you to read the electric field. So electric field, you basically, as long as you are bringing this in the middle of the two plates, it should read the electric field for you, which is 150 volts per meter. And then it is showing the direction, which is the direction is going down. So so you have to mention all of those. So when I'm asking you to change the voltage, I'm expecting you to, for example, go from, I don't know, something. Okay, so you connect you read the voltage by connecting the voltmeter to the top and down. For example, 0.53 is going to be the first voltage, the point, then around 1 volt the second voltage, then 1.25 the third voltage, and each time I want you to read the capacitance, plate charge, and stored energy, and also the electric field, and fill it out over here. So just the same way as I have done it. So you do for 3 voltages. The next thing I want you to do is to change the separation. So just keep it, so give it a random number. Okay, so give it a random number when you're starting that. Or if it is, okay, so here I didn't ask you to do a random, I've asked you to keep it as 10 and 100. Okay, so I just keep it at 10 and 100. Okay, I'm just gonna go 1, 2, and 3 different separations. Okay, so I go 3 different separations and then fill it out. Try to increase it or decrease it so that you see as a result of increasing or decreasing what is happening. And then the last one is the area. I want you to put it back fixed at 10, and then change the area 1, 2, 3 areas, and then read everything and put it there. So this is the first part. This, yeah, and then but after you filled out everything over here, I need you to go through and then answer the questions. How is the capacitance changing with the change of the voltage? So you look at your thing and then conclude something and answer those questions. The next part is put in a dielectric. So if I go to the next tab basically and put a dielectric in the middle, then the things are gonna change. So again, I'm gonna put all the things that I asked you before, and then you can move them around to make sure. So you can connect it all the way to the top, and then this one to the bottom, so that you would be able to read the voltage. So all what I'm asking you over here is randomly choose once, but don't change it afterwards. I mean the voltage, separation, and area. Give it a number. Don't leave it as it is. Give it a number. I'm just gonna go, for example, this one, this thing, and then the voltage. I just give it a voltage, and I'll just put it down. I'll just put it down what I have done, and this is for the condition of the air. So the voltage is, for example, 0.7, the area is 211, and the separation is 5.1 millimeters. So I put those, and I don't change it. The only thing I'm gonna change from now on is the dielectric material. Okay, so for the dielectric material. So it says, okay, so put the dielectric in and do exact same things as you were doing before. So put the dielectric in. So without dielectric is basically air. Then put the dielectric in. And what is the dielectric? You choose the dielectric to be Teflon, and then read the capacitance. And if these are maxing out, you can always like put it on the negative, and then make it smaller to go to the scale that you want. So I want you to fill out this by finding. So once you fill it out, you don't change it. So basically these are going to be repeated, these are going to be repeated, and these are going to be repeated. And then you see how is the capacitance changing by going from air all the way to the glass. And then how is the Q changing, how is the energy changing, and then how is the electric field changing. So electric field inside, if you look at it, for example, over here, you see that over here even I have to, if okay, so I have to put it exactly in the middle, and then if it is, I make it a little bit smaller to see the plate is 321 down, and then the dielectric is putting like 168 up, and then this summation, the total is going to be 153 volt per meter down. So I'm asking you to put the plate, dielectric, and sum over here, and then after that go through the questions and answer those questions. The third part of this lab is if you have multiple capacitors. So the multiple capacitors, I'm asking basically to look at the capacitors in parallel and in series. So I have asked to pick randomly between 1 to 3, one up, one low. So you put it, again, I'm going to put all these meters that I had before, so that if I'm asking you anything, you would be able to do the measurements. So I want like 3 in series. This is the first one, 3 in series, and I have asked you to pick 3 random numbers. So 1 low, 1 middle, and 1 high. So you give it three different numbers, and what I have asked you is go and do all the measurements that I asked you before. For example, over here I say go and find the C1 capacitance. How do you find the capacitance? It is written over here, so just remember to convert it to picofarad to be easy. So basically it's 10 to the minus 13, make it 10 to the minus 12, and then put one decimal, put the dot on the back of the 1. So it's going to be 0.12 for the C1, 0.12, 0.12 picofarad, and then the second one is going to be like 0.17, 0.17 picofarad, and then the last one is like 2.6 10 to the minus 13. It is going to be 0.26 picofarad. So I'm just going to put those things in, and then I'm going to give it a voltage. You you give it a voltage, and then read the voltage for me. So the read the voltage for each one of them. So I go from here to here. I say, okay, so how much is the voltage? It is, for example, 0.417, and then read the voltage on this one. This is the second one I'm reading for the C2, and then it is 0.29, for example, and the third one is going to be how much is, you read it from here to here, it is 0.12. So you fill it out, voltage of C1, C2, C3, and Q1, Q of the C1. This is calculate. So you basically have to multiply C by V. So you have the C, you have the V, you calculate it. And then the energy is going to be also, yeah, you got to calculate it. And then insert, read and insert is going to be the electric field. So I'm expecting you to go and put the electric field here, here, and here, and read it and put it there. So at the end, what I want you to do is calculate and also read and insert. So what is showing over here for you, the total capacitance, total stored charge, and total energy is the total of all 3 of them. So you fill it out, all 3 of them over here. And then so you have all of them. And then for voltage, you basically, in order to read the voltage for all 3 of them, you read it from all the way to the top or to the bottom and the bottom, and then it's like 0.904 is going to be the total. So you write it over. But if for each one of them, for this one you have to calculate. I have already given you the formula for the this one. You also V1 plus V2 plus V3, you add them all and then you put it here. For the Q, I said it is all equal to the same Q, and then for the energy, I said you just add them up. And then I want you to be able to compare this with this to see what your reading and calculations are looking like. Are they pretty similar or not? Or if it's not, why is it not? Or find the answer. You do the same thing with the with putting them in basically 3 parallel. So I'm not gonna go through the whole thing, but you just pick 3. You can if you want, you can be very close to what you had chosen before, but not necessarily, and then go through the same thing and all the measurements of everything for the parallel. And the very last part is going to be this part, and then you fill it out basically for the capacitance, voltage, Q, and then also calculate and read and insert the total that you had found before. Yeah, that you did it by just looking at the totals. So that's it for the first part of the lab.